when you multiplied these matrices, you got that little red matrix up there, at least you should have. That is called the identity matrix. Any square matrix with all zeros and a 1 along the diagonal like that is called the identity. Why do you think it's called that? Seriously, why do you think it's called that? Yes, because if you take a matrix that can be multiplied by this, like if the dimensions align, you should get the exact same thing back. It's like adding 0 or multiplying by 1. That is the multiplicative inverse matrix multiplicative identity matrix, for matrices. What do you think the additive identity matrix would be? That's kind of an easy question if you think about it. Yeah, exactly, all zeros. That's not going to change it. And this is the multiplication identity matrix for matrices. And everything that we do today is going to be based around this matrix. Here's the premise that we're going to use today. The premise. If I asked you a nice, simple little equation, if I turned on my Moby, and then I said 3x equals 6, what would you do to solve for x? You divide by 3. Why? You would actually multiply by 1/3 in principle because you'd be multiplying by the multiplicative inverse. Isn't that the same thing? You can solve matrices the same way. Any system of equations, let me just jump to one of the end ones and then I'll come back and show you where all this is going. All of these systems of equations you could break down as matrices. This one would be 1, 3, 4, 1, 2, 3, 1, 4, 3. And then you would write that like this, times x, y, z. And that would equal -3, -2, -6. That is a system of equations written out in matrix form. You might be saying, well, how? What? Well, look, if we multiply 1x plus 3y plus 4z equals -3. 1x plus 2y plus 3z equals -2. 1x plus 4y plus 3z equals -6. So just like that problem we worked a second ago, doesn't it stand to reason that if we multiplied both sides, remember how we just did it by 1/3, the inverse of 3? Let's call this matrix A. If we multiplied both sides by the inverse of A, it would be x, y, z, because this would basically cancel, like the 3 and the 1/3, equals, and then this product would be your answers. It would be what x, y, and z equals. So it's really just yet another way to solve systems of equations, and that's where we're going today. But before you can do that, you need to find out how you can solve for your inverses, and then you'll be able to solve these systems. Yes, we are going to have a 4x4, but the 4x4s are going to be kind of pre-solved for you. All you really have to do is multiply. Okay, so the first batch of problems is simply multiply AB and BA and tell whether they are inverses of each other. If two matrices are inverses, then you have to be able to get it in both directions. AB and BA both have to equal the identity. If you get anything that's not in the identity, you can stop and just say, no, they're not inverses. Let's look at one. Let's look at number 3. A times B, positive 8 plus 0. I can stop right now, can't I? Is there an 8 anywhere in the identity matrix? No. Now, someone asked me, they said, well, what if you got this? Could you then just divide out by 8? Well, yes, but then it's not really the same. It's now 8 times the identity, and that's not the same thing. So as soon as you get one thing that doesn't fit the identity, you can immediately stop and say, not the identity. Or not inverses, I guess would be a better way to word it. Okay, I won't erase. Not inverses. As soon as you get something that's not a 1 or a 0 where it's supposed to be. Now also, I should also say, notice all these are squares. That was done for your convenience so that you can more easily tell what dimensions your product will be. Let's look at number 9. Here we go, A times B. 7 halves minus 1 is 5 halves minus 3 halves. 5 halves minus 3 halves is 2 halves, which is 1. First row, second column. Negative 3 plus 0 plus 3 is 0. So far, so good. We're still the identity. First row, third column. 1/2 plus 1 is 3/2 minus 3/2. 3/2 minus 3/2 is 0. So far, so good. Second row, first column. And I can't erase today. 7/2 minus 3/2 is 4/2. Minus 4/2. 4/2 minus 4/2 is 0. Second row, second column. Negative 3 plus 0 plus 4. What's negative 3 plus 4? 1. So far, so good, because that's what we wanted. Second row, third column. 1/2. 1/2 plus 3/2 is 4/2. Minus 4/2 is 0. Third row, first column. 7/2 minus 4/2 is 3/2. Minus another 3/2 is 0. Negative 3 plus 0 plus 3 is 0. 1/2 plus 4/2 is 5/2. 5/2 minus 3/2 is 2/2, which is 1. So AB worked out. Now you have to do BA. But I'll tell you what, I'll make you a deal. I've never seen one of these problems in the book where it works one way and not the other. I know we're down to halftime, so I'm just going to make you try AB. Technically, though, you should be looking at both. I guess there's an example out there where it works one way and not the other, although I haven't seen it in square matrices. So today you can just try AB if you'd like. And if it works, write that it's an inverse, and if it doesn't, write that it's not. Although I've never seen one that only worked one way that they've given us. Questions about what you're looking for? If it's the identity, they're inverses. If it's not, they're not. Okay. Alrighty. Now, you're going to need this formula. You might want to write down this formula, and you may want to imply somewhere in your notes that it comes from this matrix. You need to write that it comes from this matrix, does this formula. That is the inverse formula for a 2 by 2 matrix. The inverse formula for a 2 by 2 matrix. While people are writing this down, here's a vocab question. Raise your hand if you know the answer. What did I say the other day that the order of the matrix was? Exactly. You can take any two questions off your homework today. Very good. The order of a matrix is anytime you have a square matrix, that's how many rows and columns it has. This is just saying, if you're looking at this and saying, what the heck is IQ? That's saying that it's a second ordered identity. So it'd be a 1, 0, 0, 1 matrix. This could be, if it was I to the 4th, that'd be a 4 by 4. 1, 0, like our DOM one. 1, 0, 0, 0, 0, 1, 0, 0, etc. So that's what that means. Okay. So, if you're given a 2 by 2 of standard form here, to find its identity, you need this formula. AD minus BC is called the determinant. So, let's look at 13. First thing you need to do is find the determinant. AD minus BC. So that's 4 minus a negative 4. So that would be 8. Again, AD is 4 minus BC, which is negative 3, isn't it? Oops, my bad. 4 minus negative 3, which would make that 7. That's the first part. Now, the reason you find that first is because if your determinant is 0, what do you think that means about your inverse? You can't have one. It's impossible. Because if you need the determinant to multiply through by this, and it's an impossible number, 1 divided by 0, then it's not going to have an inverse. Anytime you get a determinant of 0, you can immediately stop and say no inverse. Here we go. Now, all we have to do is scramble our original. Notice how the A and D are switched. Well, these are the same, so you're not even going to be able to tell they switched, but they did. And then B and C merely changed signs. This doesn't mean they'll always be negative. It just means you changed the sign of what it originally was. So this would be -3, +1. And there is your inverse. Now it wants you to multiply them when you're done. I'm not going to make you do that on every one of them. I would really like for you to do it maybe at least once so you can see how they work. Because, I mean, here's the thing. When you get these on the test, you're going to be like, well, how do I know if I'm right? Well, multiply by the original. If you get the identity, you're right. And that's something I want you to remember because it's like a get the answer correct free card. So, real quick, multiply that by the original, and I'm just going to do this for this one. You should get the identity back. 4 plus 3, first row, second column. 6 minus 6, second row, first column. 2 minus 2, second row, second column. 3 plus 4. Now what's going to happen when I multiply through by my 1/7? You're going to get 1, 0, 0, 1, which is the identity, so you know you did it right. Because when you multiply a matrix by its inverse, the whole point of finding that is so that they'll cancel and go away, just like 3 1/3 did back in that basic example I did. Let's look at another. Let's look at number 17. What's the first step to finding the inverse? Big D word? The determinant. AD minus BC. That's 10 minus 10. What does that tell me? I can stop right here. No inverse. Your determinant is 0. You get no inverse. Questions on that one? All right. Remember, if it's not 0, just consult this. You're just going to flip these two, change the sign on those two. Easy peasy. That's 2 by 2. And 2 by 2s are nice and simple. They have a formula. 3 by 3s, a tad more complicated. Well, first thing you have to do, no. Although I will make this the last thing we do today. We'll cut this lesson in half. Yes, 8.4. This is 8.4. Yeah, we already did 8.1 and 8.2 and 8.3. Yeah, and 8.3 was different. Okay, here we go. 8. To find an identity, let's just pick one. How about 23? To find the inverse, I meant inverse. To find the inverse of a matrix, here's what you have to do when it's 3 by 3. Unfortunately, there's no grandmaster formula. In fact, before I go any further, let me make sure I'm showing you the right thing. Yes, if I am. To find the inverse of a 3 by 3, here's what you do. Actually, I didn't write this correctly. You write you convert it. You just basically write the whole thing again. Let's do 23. So it's going to be 2, 2, -1, 0, 3, -1, -1, -2, 1. Now brace yourself. Some of you are probably going to hate this. You're going to put up a little partition, just like we did with our augmented matrices when we put our answers over here. But now you're not going to put your answers over here. You're going to put your identity over here. I know. Not pretty. That's why it's the last thing we're doing today. As such, this is one of the big reasons I did not want you guys to get in the habit of using your calculators on the last section when you did all those row operations. It's because you're going to have to do row operations again. We need to convert this side to be the identity using row operations. You need to get this side to be the identity, and then whatever you get on this side as you're doing that will be your inverse. Okay. Now, again, you can do anything you want to this matrix. Okay? As long as this side is the identity when you're finished, you can do anything you want. Now, the identity. What's going to be in the top left corner of the identity matrix? A 1. Right? So we're going to do it the same way we did. We're going to make this 1, 0, 0, 0, 1, 0, 0, 0, 1. We're going to solve it very similarly to the way we solved systems of equations the other day. But remembering that you can do anything you want, what's the easiest way to get a 1 in that top left-hand corner so we can start solving this simply? Yeah, just switch row 1 and row 3, and I'm going to actually make this negative, this whole row. That way this will be a positive 1. So we're going to switch row 1 and row 3, and I'm going to make row 1 negative. That way it'll change the sign all the way across. So, well, that's why I wrote it above it, so that would kind of, oh, touche. Row 3. Okay, so that would be positive 1, positive 2, negative 1, 0, 0, negative 1, and then the top row goes to the bottom, 2, 2, negative 1, 1, 0, 0. What? Oh, forgot to put that second part. Nope, that's just going to be your inverse. You're just trying to get the left-hand side to look like the identity. That's our whole goal. Okay, row operation time. What do I need to not wipe out in the first column? Well, no, the 1 we want to keep. What do I need to get rid of? The 2. So how am I going to do that, Alyssa? Oh, yeah, you do. What do we need to multiply this by to get rid of this? What do you need to multiply by the top row to get rid of this 2? Negative 2. I see people mouthing it. Why don't you just say it? Alright, negative 2 times row 1 plus row 3. What's the only row that's changing? Row 3. So I'm going to go ahead and write in the first 2 rows as they are. Okay, negative 2 times row 1, I'm going to write right here. Negative 2, negative 4, positive 2, 0, 0, positive 2. You have to go all the way across. That's negative 2 times the first row that I'm now going to add to the third row. So that's 0, negative 2, 1, 1, 0, 2. Let me stop for a moment. Are there questions about any step that I've taken so far? Any questions about a step that I've taken so far? No? Because that's our inverse when we're done. That's going to be our answer. When this looks like the identity, that will be your inverse. All right, now, just like the other day, we can't use row 1 again. We cannot use row 1 again to do row operations because that's just going to put a number back in for one of these zeros. So we're going to have to use these 2 to wipe out, or one of these 2 equations to knock out the other 2 columns. Now here, just like the other day, is where you have options. Yes, you could take the middle row and multiply it by 1/3 if you want to make that a nice 1 in that middle spot, but then you're going to have fractions. So what I prefer to do, and again, this is just me, I would prefer to just use random, like regular row operations, like negative 3 times this row plus 2 times this row. That way, 6, negative 6, those will cancel. And then once you've canceled these, then go back and multiply that row through by 1/3. And wait until you've already used that row before you go ahead and make yourself some fractions. What? You're not. I said that backwards. I meant the other way around. Okay, so I'll show you the first step, and we'll see if you can get the second step. So I'm going to take twice row 2 and add that to negative 3 row 1. I can add anything I want to row 1 because this isn't going to change anything. The only thing that's changing is that top row. That way, I'm going to have positive 6, negative 6, and those will cancel. What do I need to do for the bottom row? Who can tell me what I have to do for the bottom row? What could I multiply these two things by so that they're a common number that will cancel with each other? What? Yeah. Well, positive 2 and positive 3. That'll make that a positive 6 and a negative 6. 2 row 2 plus 3 row 3 will be my row operation. Which row is not going to change at all? Row 2. Row 2 is the only one not mentioned over here. That's the only one that's actually not going to change. So here we go. Row 2, unaltered, is 0, 3, negative 1, 0, 1, 0. Now, I guess I'll do these right next to each other. 2 times row 2 is going to be 0, 6, negative 2, 0, 2, 0. And I'm adding that to negative 3 times the first row. Negative 3, negative 6, this is what I wanted. Negative 3, 0, 0, 3. That's just twice the second row. Yes, thank you. Oh, what positive is? Which one? This one? Touche. Yeah. Yeah. Very easy to get lost in your signs. That's why you want to show work for partial credit. Here we go. Negative 2, negative 3, positive. Whoa, that's not right. Wait, I'm sorry. I was looking at the wrong thing. I got caught up in that negative thing. Sorry, let's try this again. Adding the black numbers. Negative 3, 0, positive 1, 0, 2, 3. That's adding those black numbers there. And that's what we wanted to do. We knocked out this, and then we'll knock out this one, and these two, even though they're not ones, will be done. We'll have zeros, 0 something 0, or we can just divide when we're done. Okay, in pink, let's do the second one. Positive 2 times the second row, which I've already got, so I'm not going to bother changing that. I guess I'll just stick it in black. 3 times the third row will be 0, negative 6, positive 3, 3, 0, 6. Adding these two black rows, you get 0, 0, 1. Ooh, that's nice. That one looks pretty much done. 3, 2, 6. We're almost done. We've only got one more column. Then all we have to do is divide something by those two middle rows. Before we go any further, raise your hand if you would like clarification about a certain step. Where I got them from, how I missed it.
What did you gain from moving that one that was already above the top of the order?
You mean that first step? What did I gain from that?
No, like the last step. We already had a one there. Are you trying to get a one?
Here?
Right there.
Yeah. What?
Why did you make that a negative 3?
I needed it to be a 1 to make my multiplication easier. Ideally, it would have stayed a 1. You're right. Technically, in hindsight, since we ended up changing it from a 1, but it made the first step easier. All I had to do was, it made this part easier. All I had to do was multiply one thing. If you can put a 1 in a handy spot off the bat, you didn't have to, though. You could have just done row 1 plus 2 row 3 and been just as well off.
No, I'm talking about that here where you did 2 R2 plus negative 3 R2.
What did I gain from doing that?
Yeah, what did you gain?
We're no longer going for upper echelon anymore. Remember the old way, we were just going for that triangle of zeros when we were solving? We're not solving anymore. We need to get this to be the identity. We need for everything to be zeros except here.
So we're not trying to get a 1.
We are, but our first priority is to get all these to be zeros. Because here's the thing, even if this is 37, 43, and 805, if all the rest of them are zeros, then I can just go, hey, I'll multiply this row by 137. Now it's a 1. This row by 143 or whatever I said. Now it's a 1. So if we can get these zeros, then this last step will just be multiply that. Nice and easy. That answer your question? Good. Other questions? Where something came from? How I added something? Anything? All right. We only have one more set of complicated row operations left. Let me get myself some more space. Bang. Okay, now we've already used row 1 and row 2. Which row do we have to use to knock out the third column? Row 3. And it'll always work like that if you do it correctly. Use row 1, column 1. Row 2, column 2. Row 3, column 2. Now, again, this doesn't apply to this problem, but let's say, going back to what Drake said a second ago, let's say after this step, before I'd written all the stuff in here, let's say this had been a 1. Okay? I would have switched those. Just because, since I'm going to use that row, it would have made this part easier. But I couldn't do that, so none of them were a 1. Also, if this had been like 3, 3, 6, 9, and they're divisible by something all the way through, you're more than welcome to stop, just like in the last way we did this, and be like, hey, I'll multiply that row by 1/3. Now it's a 1. But again, I couldn't do that without making fractions. So I'm not using a lot of things I could have used. All of you are probably going to work this differently. You could do this literally infinitely many different ways. Maybe not literally. Okay, here we go. What can I do to the third row to make it knock out the top row? Very good. You said -1? Good. Negative row 3 plus row 1. That'll make that a -1, +1. Vamonos. What about these two? I'm hoping there's a silence because you realize it's kind of a trick question. You don't have to do anything. They already are opposites of each other. So just add them. Row 3 plus row 2. Here we go. What's the only row that's not changing? Row 3. So 0, 0, 1, 3, 2, 6. Negative row 3, I will write here at the top. 0, 0, -1, -3, -2, -6. Adding that to the top row, you get -3. You're delaying me, board, with your glitchiness. Negative 0. I have to reset this thing again. I hate doing this. 0, -3, 0, -3. Okay, now row 2 plus row 3 as is. 0, 3. Come on. I'm just going to go on. That's a 3. 0, 3. 3. Good, you're a genius, Jared. Just use my mouse. It's not going to look pretty, but I'm not a right-handed mouse user. 3. Let's see. 3 and 6. Okay, we're all but done. We're all but done. We have our identity shape. What's the only thing we have left to do? Top row needs to be multiplied by what? -1/3, so that'll be a +1. And what does this row need to get multiplied by? +1/3. So I'm just going to write that right here in the margin. -1/3 row 1, +1/3 row 2, and we'll be done. That's going to make this 1, 0, 0, 1, 0, 1, whatever. 0, 1, 0, 1, 1, 2. I'm not going to promise you're not going to get some today with fractions. That's a very distinct possibility. And then 0, 0, 1, 3, 2, 6. And this right here is your inverse to your original. The left side is the identity. There's your inverse. If you want to check it, multiply it by your original. You should get the identity back. I wouldn't blame you. There's your inverse. Any final questions about this problem? The last thing I'm going to have you look at, and I'm going to cut this Simon in half. What numbers did those go to? That went through number 27.
So, I'll tell you what.
Hold on. Let me look at this one more time real quick. What the one we do? 23? Let me make sure I don't leave a section out. Are there more than 4 problems in every section? You would have to do at least one of those. Alright, I know what I'm going to do. I know what I'm going to do. 2 through 18, even, and then 24. Nope. There you go. Come on, you know you fit. There we go. There is your assignment. Yes.